All right, so severe thunderstorms, not just regular thunderstorms, we'll get our alerts by the National Weather Service. Here in Southeast Iowa, that would be the Quad Cities, who actually posts our watches and warnings for thunderstorms. They actually are a different group of folks than that give us our what we call the convective outlook, come from folks in, I believe, Norman, Oklahoma. So the forecasts and the warning and watches may, like in that case, come from different places. But so for the National Weather Service to go ahead and issue either a watch or a warning. Now remember, a watch means that conditions are favorable, and a warning means that it is happening and headed your way. So watch is less freaking out, and a warning should be really much freaking out. So notice the things that trigger a thunderstorm warning would be wind speeds, and they need to be faster or at least or 58 miles per hour or greater. And the system, the thunderstorm system or the cells associated with that thunderstorm need to be creating hail and or hail that is at least 1 inch in diameter. Now you can see that it used to be 3/4 of an inch, and they've increased that. Another criteria that could create or prompt them to issue a warning would be if the system has been known to spawn tornadoes. If there's a tornado now associated with it, or it has been in the past associated with it. Now, knowing whether or not there's a tornado associated with a thunderstorm, there are things that meteorologists, fancy gizmos, I suppose radar, and maybe to a lesser extent satellite, that meteorologists can look at to know that we have actually a tornado going on within a system. But more than even that, they really kind of count on trained spotters. So again, if you have never been to a spotter training put on by the National Weather Service, I think you should put it on your calendar of things to do. They happen in the springtime. So severe thunderstorms. Now, when we talk here in a minute about actually these weather systems that have more than one thunderstorm cell going on, oftentimes they will bring severe thunderstorm weather. And we're going to see that what happens with a system that has multiple cells, when I'm talking about a cell, I'm talking about an individual cell that goes through the cumulus, mature, and dissipating. Basically, what we'll see within a system of multiple cells is they kind of feed on each other and they encourage each other to develop. Severe thunderstorms, sometimes if you are at the right vantage point, you can see something called overshooting tops. Let me go ahead and draw my cumulonimbus cloud. Here's my anvil. Overshooting tops basically have overshot into the tropopause. Now that isn't very good. This is the down part, and here's my precipitation. Here's my A for anvil. This up here was supposed to be my overshooting top. And you may or may not be able to see the overshooting top. You kind of have to be a little ways away. But if you see that overshooting top, that means that there's a fair bit of instability associated with that, a fair bit of lifting going on within that thunderstorm cell. Wind shear actually is one thing that can help keep your thunderstorm going. What wind shear can do is basically kind of keep the updraft away from the downdraft. So for instance, I'm going to show you over here a majestic cumulonimbus cloud. I'm going to try to. There's my lifting condensation level. Here's my anvil. If it's majestic, it's nice and straight up. Now, one of the things we know that is if you go up in the troposphere, you reach greater and greater wind speeds. So here we go. This arrow is kind of showing wind speeds. Okay, so we get faster and faster winds. Now, if we have a fair bit of wind speed differences, so I'm going to try to kind of exaggerate it. What the vertical kind of shape of a thunderstorm sometimes can be tilted. And I'm kind of just trying to show a tilted one here. Here's my anvil, trying to show that it's tilted. And this sort of tilted thunderstorm, I don't know if you can tell the difference here, what I'm trying to show. But what this tilted thunderstorm tells us is that we have a fair bit of wind speed, wind shear going on within the cloud. And with that, actually, we can have an ingredient later on for creating this mesocyclone that actually can spawn tornadoes. So tilted cumulonimbus clouds are a potential issue. So versus, we call this majestic over here. Make sense? Okay. So with regard to severity, sometimes we'll look for kind of a tilted cumulonimbus cloud giving us some issues. A few other things associated with severe thunderstorms that bring us severe weather would be something called a gust front. And actually it's created by the what we call the downdraft in the mature stage of a thunderstorm cell. Let me just go ahead and quickly draw a cell that is in its mature stage. It has its updraft, it has its downdraft, and associated with the downdraft, of course, is precipitation. And I kind of told you how actually we have evaporative cooling and such, and actually this downdraft, there's like a fair bit of energy and motion and actually wind associated with this downdraft. And it can create what we call, as that wind splashes in both directions, it can create what we call a gust front. And I'm kind of drawing it here, but there's a figure from your textbook that does it even more justice. The gust front then can take some of this bottom of this cumulonimbus cloud and create what we call a shelf cloud right here. Shelf cloud. Just put shelf there. And then also associated with the shelf cloud, sometimes we can get a hot dog looking sort of thing called a roll cloud. And to understand the roll cloud, it would be kind of in this vicinity, and it would come in and out of the board as I've drawn it. So see, I told you that there was a figure from your textbook that did it a lot, did a better job than I did. So here we have, hopefully you can see the red. It's really good. It shows you the updraft. You kind of see the anvil portion up here. We see the overshooting tops. We see the downdraft. And remember, we have evaporative cooling, so not only do we have precipitation falling here, but literally we have a movement of air down. And it's that movement of air that creates a wind we call a gust front. You've probably felt this before. If you're over here nice and dry and you hear, and there's a thunderstorm headed your way, if you felt kind of a movement of air towards you, that was the gust front. So there. One of the things I wanted to kind of point out is they tell us in spotter training class, and I've been to spotter training for maybe 4 or 5 years. There's always something new to learn. But the anvil actually shows us the direction of motion of the thunderstorm cell. So here's the roll cloud. So actually, do you see where, if this is the gust front, it kind of creates a shelf cloud, then actually within the shelf cloud is the roll cloud. And roll cloud, it would be kind of like a hot dog, kind of coming in and out of the board. So this actually is showing you kind of the roll cloud, looking at it front ways versus kind of edge on.